Today, my topic is about 8086 microprocessor and its architecture, programming, and system design. Myself, Anubhab Sarkar, Assistant Professor, EEE Department of SBIST. So let's get started. And first, we have to know the overview of 8086 microprocessor. That is, the 8086 microprocessor developed by Intel, which you already know, in 1978, is a 16-bit microprocessor that signifies the dawn of modern computing. It introduced several key features that enhanced processing capabilities and set the stage for future microprocessor design. That is, it marked the beginning of the modern computing, which you all know nowadays. Next one is the key features. What are the key features? In key features, there are 4 points. First one is the instruction queue. The 8086 includes an instruction queue that can store up to 6 instruction bytes from memory. This features allows for faster processing as it enables the microprocessor to prefetch instructions before they are needed for execution. Second one is the architecture. It was the first 16-bit processor to incorporate a 16-bit ALU, that is arithmetic logic unit, 16-bit registers, and both internal and external data buses. This architecture significantly improved the speed and efficiency of data processing, which is needed very efficiently. Next one is the variants. The 8086 is available in three different versions based on their operational frequency. First one operates in 5 MHz, second one operates in 8 MHz, and the third one operates in 10 MHz. Next part is the pipelining. So what is called pipelining? The microprocessor employs a two-stage pipelining process. First one is the fetch stage and the second one is the execute stage. In fetch stage, prefetches instruction and stores them in the instruction queue, which we already know, and in execute stage executes the preferred instruction, thereby improving the overall performance. Next point in key features is interrupt handling. In interrupt handling, the 8086 supports 256 vectored interrupts, allowing for efficient handling of various interrupt requests. And the last one is the transistor count. The microprocessor consists of approximately 30,000 transistors, showcasing the complexity and capability of its design. And next part, the next slide. 8086 microprocessor architecture. As you all know, in the block diagram in the right hand side, we have to discuss what is in the block diagram. The 8086 microprocessor introduced in 1978 efficient processing capabilities. Architecture overview means the architecture of 8086 can be divided into two main units. First one is the bus interface unit, that is BIU, which provides the interface between 8086 and external memory and input-output devices via the system bus, which also responsible for various machine cycles, including memory read and input-output read operation, facilitating data transfer between memory and input-output device. Next one is the execution unit. In execution unit, it fetches instruction from the instruction queue in the BIU, decodes them, and executes arithmetic and logic operation using the ALU, which also sends control signals from internal data transfer operation within the microprocessor. Next point under block diagram is prefetch unit. This is the component of BIU, that is the bus interface unit, which fetches instruction from memory and stores them in a queue. Allows the 8086 to perform multiple instruction fetches in parallel, enhancing overall performance, which also include the registers. So what are the registers? The 8086 microprocessor features several type of registers. One is the general purpose, that is AX, BX, CX, and DX. Full form is AX means an accumulator, BX means base, CX means count, and DX means data. Next one is the segment registers. In segment registers, there are four types: CS, DS, SS, and ES. That is code segment, data segment, stack segment, and extra segment simultaneously. Third one is the pointer or the index register. In pointer, IP, that is instruction pointer, SP, stack pointer, BP, base pointer, SI, source index, and DI, destination index. So after register, we have to know the 8086 microprocessor architecture. In architecture, we already known about the BIU and the execution unit. Next part is the instruction processing. In instruction processing, the 8086 microprocessor employs a pipelining technique which is already known in the first slide, allowing it to fetch, decode and execute instruction in parallel rather than sequentially. This is achieved through first one is instruction fetching, that is the BIU continuously fetches instruction and fills the prefetch queue. Second one is decoding and execution. Once an instruction is ready, it is decoded in the instruction unit, where data is fetched from general purpose register, that is GPRs, and processed by the ALU. Third one is the dynamic flag register. In dynamic flag register, the flag register values changes dynamically based on the results of arithmetic operation, providing status information about the outcome of operation. Next is the addressing mode. Addressing modes are crucially in assembly language as they define how an instruction identifies the data or operands it operates on. Understanding these modes is essential for effective programming and optimization in microprocessor architecture. So let's get started with the types of addressing mode. First one is the register mode. In this mode, both operands are located in register. What are the characteristics? Fastest mode due to direct access to register and commonly used for operations that require quick data manipulation. And examples are MOVAX and BX, that is moves the content of register BX into register AX. Next example is XOR AX and DX performs a bitwise XOR operation between register AX and DX. Third one is ADD, that is add AL BL, adds the content of register BL to register AL. Second one is the immediate mode. In this mode, the source operand is a constant value. Either it may be 8-bit or 16-bit, while the destination operand is typically a register or memory location. What are the characteristics? The immediate value is directly specified in the instruction, making it easy to use for constants. The destination operand cannot be an immediate value. Special note. And what are the example? As it is immediate move, so examples are MOVAX 2000 loads the immediate value 2000 into register AX. 2000 is the register, and second example is MOVCL OA loads the immediate value OA into register CL. Third one is ADDAL 45 adds the immediate value 45 to the content of register A. So this is immediate mode. Next one is displacement or direct mode. In displacement or direct mode, the effective address of the operand is directly specified in the instruction as a displacement value. As a characteristic, it has simply and straightforward as the address is explicitly given, and it is also useful for accessing fixed memory location. In examples, move AX DISP, that is moves the content at the memory address specified by DISP into register AX, and move AX 0500 loads the content from memory address 0500 into register AX. Fourth one is register indirect mode. Here, the effective address of the operand is stored in a register such as SA, DI, or BX. As characteristics, it provides flexibility in accessing data as the address can change dynamically. It is also useful for accessing arrays and data structure. Examples are MoveAX, MoveAL, ADDAL, and MoveAX. Fifth one is based index mode. In this mode, the effective address is calculated as the sum of a base register and as an index register. It combines the benefits of both base and index register, allowing for complex data access patterns, ideal for accessing elements in data structure like arrays. Examples: MoveAX, BX plus SI. Next one is based indexed mode. In this, the effective address is calculated as a sum of a base register and as an index register. As an example, it can be written as move AX BX plus SI moves the content from the address calculated by adding the values in BX and SI into AX. Seventh one is the index mode. In this mode, the effective address is determined by the sum of an index register and the displacement value. As an example, move AX and move AL. Based mode. Now, in this mode, the effective address is the sum of a base register and the displacement value. It provides a straightforward way to access data relative to a base address. Example, move AL. The 10th one is the base index displacement mode. This mode combines the base register, index register, and the displacement value accumulated to calculate the effective address. It offers maximum flexibility for accessing complex data structure. Example, move AL. And the last 2 points are string mode. In string mode, the addressing mode is specifically related to string instruction. It utilizes the source index and destination index register. As an example, move SB, move a byte from source to the destination. Input output mode. Next one. The mode is used for input and output operation. It facilitates communication between microprocessor and peripheral device. Example, in A45, out A450. The last one is the relative mode. In this mode, the effective address is calculated relative to the instruction pointer IP. It is useful for branching and control flow instruction. Example, ZNZ8, which jumps to the address calculated by adding 8 to the current instruction. So, up to this, it is clear. Thank you.